is possible for a single observation to have a great influence on the results of a regression analysis. It is therefore important to be alert to the possibility of influential observations and to take them into consideration when interpreting the results. The influence of an observation can be thought of in terms of how much the predicted scores for other observations would differ if the observation in question were not included. Cook's d is a good measure of the influence of an observation, and is proportional to the sum of the squared differences between predictions made with all observations in the analysis and predictions made leaving out the observation in question. If the predictions are the same with or without the observation in question, then the observation has no influence on the regression model. If the predictions differ greatly when the observation is not included in the analysis, then the observation is influential. Two factors determine the influence of an observation: leverage and distance. The leverage of an observation is based on how much the observation's value on the predictor variable differs from the mean of the predictor variable. The greater an observation's leverage, the more potential it has to be an influential observation. For example, an observation with a value equal to the mean on the predictor variable has no influence on the slope of the regression line, regardless of its value on the criterion. On the other hand, an observation that is extreme on the predictor variable has the potential to affect the slope greatly. The distance of an observation is based on the error of prediction for the observation. The greater the error of prediction, the greater the distance. However, even an observation with a large distance will not have that much influence if its leverage is low. It is the combination of an observation's leverage and distance that determines its influence. This table shows a small data set consisting of 5 observations. The leverage, distance, and influence of each observation is shown. Observation E has by far the largest leverage and the largest distance. This combination of high leverage and high distance makes this observation extremely influential. This graph shows the regression line when observation E is included, the blue line with the lower slope, and when observation E is excluded, the red line with the steeper slope. As you can see, the two regression lines are very different, indicating the influence of this observation.